Hola, Berclair boys and girls. This is Mr. Jones again. Fifth grade math. Today, what we're going to be doing is solving word problems. All right. This is another review lesson, of course. All right. The I can statement. Can you say the I can statement? I can use reasoning skills to solve word problems. Our essential question is how does annotating word problems support my reasoning skills? All right. That's the important question of the day. That's our EQ. All right. Our Common Core standards are 5NFA1 and 5NFA2. All right. We will be working with fractions during this lesson, but mostly we're going to be learning how to solve word problems again using those estimates to mentally assess the reasonableness of our answers. All right. My expectations for this video is that we try all problems with pencil and paper first. So I want you guys to go ahead and take out a sheet of paper, get a pencil, and I want you to do the problems with me. All right. I do want you and I expect you to watch the entire video. Email your pictures to the email that I provided for you in the description. Complete follow-up lessons on khanacademy.org. All right. I assigned those to you before we went on our break. Okay. If you need any of your email or, not your email, your login information, just email that email in the description asking for your Khan Academy password and login username. All right. I want you to keep all comments directed toward me at all times. This is a very important piece here. So no messaging strangers. And I try to, unless we are going to do a group discussion, and I'll let you know how we do that. I don't want you guys even messaging each other. So when you're on there, you're talking to me. All right. I want to send some shout outs because last week we had a challenge problem and very few people accepted the challenge. I was shocked. But I know that after we have not been in practice for a while, we're a little rusty and we get a little intimidated or a little shy. Or maybe some of you guys just joined in so late you didn't see the video. But I want to send a shout out to these heroes right here. Malak, Yahira, Ahmed, Jimena, Mariah, Angeli, Eunice, and Eduardo, because they accepted the challenge. They attempted to do the problem. All right. They did their best. So I want you guys to remember that leaders, they run toward challenges, not away from them. All right. I have that at the bottom of the screen. I'm not sure if you can see it, but leaders run toward challenges and not away from them. All right. So we're going to do word problems today. And there's a certain approach that we need to remember on how to approach a word problem. One doesn't simply solve a word problem. All right. First thing I want you to do, I want you to take a rare approach. I want you to read. All right. I want you to read the entire problem. Yes, the entire problem. Read it. All right. The next thing you're going to do is you're going to annotate it. All right. That's underlining and making bold or circling or whatever you do, star, asterisk, whatever floats your boat to help you remember what you're using. But the next step tells you why you're annotating. You're annotating so that you can render a problem. All right. You want to be able to render a numerical expression that has a relationship to what's going on with what you annotated. So you're showing how those numbers are related to each other in order to get information out of that text. All right. And so the R could also be part of the read, draw, write approach, which we use our tape diagrams or any type of visual that you use. If you need to read, draw, write it down, whatever helps you to solve the problem, that's what you use. All right. So you're going to render the problem, or you're going to use the redraw write, and then you're going to execute. Doesn't that make sense? You're going to execute the problem. You're going to actually solve it. All right. And there's a particular way that we execute word problems in order to give a final answer. Do you remember? We give what type of responses? That's right. We get full sentence responses when we're working with word problems. All right. So I want you to remember the point of this approach is we're trying to make getting the wrong answers a rare occurrence. All right. We don't want that to happen. All right. It may happen. It happens to us all. But guess what? We're going to make it rare. All right. Because we're going to follow procedure in this approach. All right. So I'm going to introduce last week's challenge question again, and I'm going to show you how it was supposed to be solved, and we're going to go over that rare approach here. All right, so watch me use that approach in this one. All right, there are 18 million healthcare workers in the United States right now, according to the CDC, Center for Disease Control. They need N95 masks to protect them from catching the coronavirus while treating patients. The mask is no longer effective and must be changed after 8 hours. However, the average healthcare worker works between 8 to 12 hours. Right now, notice I'm not going to stop there. I'm going to keep reading because this is obviously a part of the problem as well. How many masks are needed for the healthcare workers of the US for one day? How many masks will be needed for the healthcare workers for 6 months? All right, so they're asking for two different things here, it seems. All right, so we're going to go back and we're going to annotate in order to find out what we need in order to solve this problem. All right, let's go. Notice that I underline 18 million. Why did I underline 18 million? No, it's not because it was a number. All right. I want you to notice something. There's a number in N95. There's a number in 8 hours. There's a number in 8 to 12 hours. Do I just want to underline everything that has a number in it in a word problem? No. I'm underlining this because it seems to have essential information that I need. There are 18 million healthcare workers. Well, if I go down to the bottom, this last sentence includes something about healthcare workers. Every part of this problem has a phrase in it about the healthcare workers. So that's my telltale sign that the number that precedes that may have something to do with the problem. So I'm going to underline 18 million. All right. N95, I'm looking at it. Context clues. N95 is a type of mask. It's the name of a mask. All right. So I don't need to underline that, even though there's a number there. All right. It says the mask will no longer is no longer effective and must be changed after 8 hours. Hmm. All right. Not giving me a lot of information there is what as far as what I could use to make a some sort of algorithm or equation, but I'm gonna keep reading. This is however, the average healthcare worker works between 8 to 12 hours. Wow. That's interesting. Well, it hasn't asked me for anything yet, so let me go down to the first question. How many masks are needed for the healthcare workers of the U.S. for one day? For one day. Well, it tells me here, and this is where this information becomes really tricky, but also it gives me part of my answer, is that we know that the mask must be changed after 8 hours. All right, but the question is, how many hours are they working per day? All right, so each healthcare worker in the United States works between 8 to 12 hours. So it looks to me that if they're going to exceed 8 hours, they're going to need an entirely new mask in order to stay healthy, because we learned that after 8 hours, that other mask is no longer effective. So they're going to need two masks per person. Well, what does that mean? I'm going to underline that. I'm going to put times two, just to remember that this means times two of the mass for one day. Okay. So I'm going to multiply what? What do you think I'm going to put here for A? So I want you to pause the video if you need to and go ahead and um, build a expression that would express so far what we have after we've looked at question one. What does that expression look like? You're correct. 18 million times 2. 18 million healthcare workers, those are the people, times the 2 masks that they need a day will give us the total number of masks that they need, which is 36 million masks. Wow, that is a lot of masks. All right. But are we finished? No. All right. So the question two, it asks how many masks will be needed for the healthcare workers for 6 months? Well, wow, let's look at that. There's something here that you should know automatically when I threw in this unit 6 months. That's right. There's a unit conversion here. All right. So we're going from a smaller unit of I'm sorry, a larger unit of months to a smaller unit of days because we need to know how many days are in 6 months in order to answer this problem. So now that you know that, how would you set up this problem? That's right. So for 1 month equals 30 days. All right. And 30 times 6, that's the 30 days times the 6 months, right? Our smaller unit times our larger unit equals 80 days. I'm sorry, 180 days. All right. Are we finished once we got our 180 days? No. We just found out that there were um, 180 days within 6 months. Now, part of mathematics and solving word problems is knowing when you have your answer. That's the reason why you have to pay attention and you have to make sure that you know what your numbers mean. And that's part of the reason why we always answer in a full sentence because our full sentence answer lets us know what we're answering. All right. And so, in order to answer this question, how many masks will be needed for healthcare workers for 6 months? Well, we know that for one day, they're going to need 36 million masks. So now we need to multiply that times the 180 days that are in 6 months, which would give us an answer of 6,480,000,000 masks. All right. Said in a full sentence, for 6 months, healthcare workers in the U.S. will need about 6,480,000,000 N95 facial masks for 6 months. All right. Notice that I use the word about because remember, these are just estimates that we're working with. All right. All right. What did you learn so far about applying the rare method here? When I say the rare method, how is annotation helping you reason with your problem? Did underlining 18 million and understanding that 8 to 12 hours shifts meant that they were going to need 2 masks, did that help any in solving the problem? If so, explain how in the comment section. So go ahead and pause the video and do that. All right, moving on. So what we're doing is we're applying math to real world situations. I never want you guys to lose focus of what's actually going on when we're doing these word problems. We're extracting data, we're getting information out of these problems. So we're going to go through this rather quickly, but I want you guys to follow the visuals. All right. It doesn't take long. All right. I'm going to read the problem first. Last week, the CDC reported that 557,488 people in the United States has the coronavirus. However, 32,697 of that population recovered from the virus. Sadly, 21,912 of that same total died due to complications associated with COVID-19. How many people have COVID-19 today? And remember, COVID-19 is our way of talking about the novel coronavirus. So when you see the word coronavirus, your question should be which one? And the one that we're talking about is COVID-19. All right. So I digress. Let's go back to the question. How many people have COVID-19 today? All right. Notice that I just annotated the problem. All right. So I underlined the numbers that I thought were significant in this problem. Did I underline all of the numbers? No, because COVID-19 has a number in it also. So there's a point that I'm making here because sometimes we fail to read the problem and understand where we're getting numbers from. And we will just work with numbers any kind of way and come up with any kind of answer. But notice I'm very picky when I'm and selective when I'm making choices about what I'm going to underline. So there's not an entire sentence underlined here. I don't need the entire sentence. I just need to know what I need in order to build an expression. All right. So we're going to move on to a redraw right method. So we're doing the redraw right method right now. So I've read it and I'm going to draw something that represents it. All right. I've already annotated the problem. I'm going to draw something to represent what I annotated. Okay. And so if you notice here, all right, I have a line here that's kind of keeping me on track with what's going on in the problem. All right, so what does the 557,488 bar represent? That's right. The total people that the CDC reported having the coronavirus in the United States. All right. So you can say that that's our total. It's the biggest number that we have. That's the number of people that we know that have had the coronavirus. All right. Now, as we progress in our reading, it says, however, 32,697 of that population recovered. So I have that here. So we're trying to draw something that represents what's happening here. It says of that population. So that and of that, in other words, you can say from that population. And from, all right, is usually a word associated with what type of operation? That's right, subtraction. All right. And as we continue reading, it says 21,912 of that same total. That same total of what? That same population right here. All right, died due to complications associated with COVID-19. So unfortunately, death, when you see that, unless you're reading the problem and it's an addition problem, you can read that. That means we're subtracting. If these people died, they're no longer with this population here. So again, you have to use your reasonableness and sometimes just common sense in order to answer these problems. All right. And so what we're looking for is right here because this is our what's left over, okay? So far we're understanding that we're subtracting, all right? We're subtracting from 557,488 and we're looking for the what? That's right. We're looking for the difference. All right. So right here, I've created an expression that represents what we just saw. All right. This is our 557,488 subtracted by 32,697. All right. Minus 21,912. Now, why did Mr. Jones put this in parentheses? And why does it matter? Now, last week, Mr. Matthews went over the PEMDAS lesson. So what does the parentheses tell you? How should we go about solving this problem? What's a real priority here of solving first? That's right. We're going to solve what's in parentheses first because that's the P in our PEMDAS, in our order of operations. All right. And so when I subtract these numbers, the difference is 514,791. And I'm carrying my 21,912 over here again, rewriting the expression as a new expression, because I understand that this did not solve our problem. This solved part of our problem, but we still have some subtraction left to go. Our total is 502,878. 502,878 people have COVID-19 in the US today. Now, it didn't take me long to solve that problem at all. It probably even took me longer because I'm working with this platform. But I wanted you guys to be able to see how annotating would help you solve a problem and be able to make sense out of it, and even using a visual like the read, draw, write method if you needed to. All right. So I'm going to leave you with this. This is a gift from me. You get the chance to make a choice. You can solve this word problem, or you can create one like it and solve it. All right. But what you have to do is you have to send me what you wrote. So I want you to rewrite this problem, and I want you to put it on paper and solve it. Solve it. Take your time to solve it. The answer must be in the full sentence. All right. Or just write the one that you created. Excuse me, the one that you created yourself, and make sure that that answer is also in the full sentence. Email me the picture to my email address, cory.jones@memphistr.org. Thank you guys so much. You guys are always great. I can't wait to see what's in that comment section. Y'all have a great day.